There we go. Okay, so wherever you are, pause real quick. I'm going to save you a little bit of work. On the back side, for 51 to 66, a couple things. One, that's a typo. That should be an F. So on B, you're supposed to be finding G of F of X. Apologies for that. And then just cross off part D. We don't need to do both of those. So that's that. Okay, and we have to do two things. We're going to do these two problems on the front side here, and then we also have to finish the notes. So let's do this. We're going to do 15 and 17. Okay. Or 19. Sorry, 19. 15 and 19. All right, so here we go. 15 causes of trouble. Now, there's no roots. Remember, we have our two kind of things. Two rules. We don't like 0 on the bottom, and we don't like negatives under roots. I only have the fraction part to worry about here, but you have two fractions. That's what makes this messy. There's a fraction inside a fraction. So here's how we want to think about finding domain. And if you're struggling at all, please, please, please draw yourself a number line to start with and think about the domain starts with everything. We always assume it's everything, and then we start pulling stuff out. So do one fraction at a time. The first fraction, what's the denominator of the first, like this inside smaller fraction? X minus 1. That denominator, any denominator, cannot be 0. So that's kind of our first inequality. Now, look at the big fraction. What's the denominator of the big fraction? 4 over x minus 1 minus 2. It also cannot be 0. Okay, we're going to solve these one at a time. And whatever we get, we'll pull out. So this one's easier. How do I get this x isolated? Add 1. So x cannot be 1. So I go on marker 1. 1, you're out. We're going to kick you out. 1 is not in the domain. Everything else is still fine, but 1, we're kicking you out. Okay, next one. I want to get that x isolated. Easy stuff first. Kick the 2 over to the other side. So 4 over x minus 1 cannot be equal to 2. Now, before you get lost in the algebra, which we're going to carry out, but just make sure we don't get lost, don't lose the forest for the trees. Think about this. I want this fraction to be equal to 2. What do I want the denominator to be? 4 divided by what is 2? So 4 divided by 2 is 2. So I want so if the x is 3, that's going to give me a 2, right? So I know immediately that I'm going to kick the 3 out. Now we're going to let's do the algebra real quick. But just make sure you're thinking about why the algebra works. And again, if I go back to the original, 3 minus 1 is 2, 4 over 2 is 2, 2 minus 2 is 0. So that's why we're kicking the 3 out. Algebraically, it looks like this. Anytime you're stuck with a variable in the denominator, you have to clear it out. So we do a thing called clearing the denominator. You multiply both sides by the entire denominator. Cancels on the left. I'm going to go ahead and distribute this. I get 2x minus 2 on the right. And then it's just pretty basic from there. Add 2 to both sides. So I get 6. Divide by 2, and x is not equal to 3, which again, we already kind of knew. All right, you got your two fractions. You got your two values that would make both those denominators 0. Everything else counts in the domain. Everything else, and what we mean by that is plug in any other number, it'll work. You won't get any problems, any errors. And you just need to take that number line and write it in interval notation. So we would say negative infinity up to 1, kick the 1 out. 1 to 3 is okay. And then 3 to infinity is okay. Okay. Let's go to 19 really fast. Okay, 19 has two things going on. First of all, you've got a root. Yeah, what's true about a root? Whatever's under there has to be greater than or equal to 0. Okay, but also you've got a denominator. So we got both situations going on. Whatever's in the denominator, this entire denominator cannot be equal to 0. So think about that. Very similar, but also different. Think about the similarities and the differences. Both involve 0. The one has to be greater than or equal to 0. That's the stuff under the root. But the entire denominator just straight can't be 0. We solve these separate. This one says x must be greater than or equal to 3. So again, think about a number line. Mark the 3. What part's getting kicked out here? Okay, we get to count the stuff greater than 3 or 3 itself, but anything left of 3 is out. So inequalities kick out a lot of stuff. The fractions, it's like single numbers. Inequalities, it's whole chunks of the number line. Okay, solve this one for x. What do we get?
Square both sides.
Square both sides. 0 squared is just 0. Add 3, so x cannot be 3. Now, 3 was okay over here, but it's not over there. So do I get to keep the 3 or not? No. You got to make both things happy. So we have to basically remove the 3, open circle it. Read your number line, interpret it into interval notation. So I get 3 to infinity is okay, but it is not inclusive. So be careful with phrases like, I always hear people say things like, if it's a root, I always get to use a bracket. The word always is dangerous. It's always things are rarely true. It's always conditional. So make sure we're just thinking about those two rules. The always things are this. We always can't divide by 0. We always can't have negatives under roots. Okay, now go find the note sheet. We have to find the note sheet here really quick. We just have to do these last couple examples. And away we go. Example 6. Example 6, we're going to form composite function and find its domain. And this can get a little messy, so we're going to kind of write down a couple steps here, okay? So finding the domain of composite functions. And it's really actually 3 easy steps. I mean, simple steps, not necessarily easy, but simple. Step 1, you're going to just find f of g of x, but don't simplify. Right? We don't want to simplify. We have to keep things kind of pieced out. We don't want to start combining stuff. Step 2 is go ahead and find the domain, as we would on the front, like in those problems we're just doing. And then 3 is to go ahead and simplify. And I kind of like to say step 3 is somewhat optional. The back of the book's going to do it, so if you're checking your work, you want to. There's some really good skills we learned by doing so, but in practice, a lot of times we just don't really care. So let's give this a go. For A, are we okay on that O symbol? Pick that up from the notes yesterday. Just means f of g of x. Put g inside of f. So in this case, we're going to take all of g, which is 3 over x. We're going to copy it. We're going to paste it on top of the x for f. So it's going to look like this. 2 over 3 over x minus 1. And that's my composition function. I'm going to resist the temptation to simplify. Just leave it like that. Okay. Now we got to find the domain. This looks a lot like number 15 that we just did. In fact, it's almost identical to 13. So if you're looking for 13, this is what it's going to look like. The problem is I have 2 fractions. So here's the first fraction. That fraction's denominator cannot be 0. Think about a number line. I'm going to kick stuff out that doesn't count. So that one's already solved for me. What can x not be?
0.
0. So I'm going to go to 0 and kick it out. 0 is not part of my domain. The second and larger denominator is the entire space here, the entire denominator, the big one. So that says 3 over x minus 1. That also can't be 0. How should I go about solving for x there, isolating the x? Plus 1 plus 1. 3 over x can't be 1. I have a x in the denominator, so I'm going to clear it out. But again, just think logically, what do we know x is going to be here? 3. Because 3 over 3 is 1. So the algebra looks like this. Multiply by x on both sides. So 3 cannot equal 1 times x is x. So that's from the blue part, from the big denominator. We go mark 3 and say you're out. Also, what's left behind? Or yeah, the whole 2 is left behind, and a lot of other numbers. 0 to 3 works. Negative infinity to 0 works. 3 to infinity works. So we just look at the number line, see what we pulled out. Whatever is left is our solution. So we would say negative infinity up to 0. No, forget that middle piece. It's easy to forget. 0 to 3. And then 3 to infinity. Okay. Now, again, I'd be happy if you kind of stopped. Like, that's your composite function. That's part A. This is part B. But if you're looking in the back of the book, they would want you to take this one step further and kind of simplify it. So we'll show you what that looks like really quick. So if I have 2 over 3 over x minus 1, and this is a good skill that we should think about. We call this a complex fraction. I don't really like complex fractions. We'd rather this little x not be there. How do I get rid of an x that's in the bottom? Multiply by x on top, so like x over 1. Now if I do that, I have to do it on the bottom and the top, so it looks like this. So the top of the fraction, I have 2 times x over 1. Again, everything's a fraction, so just straight across the top, straight across the bottom. What's 2 times x? 2x is all I'm going to do. Just multiplying the top by x. And then what happens on the bottom? 3 over x times x. The whole point of doing this is those x's cross out, and I'm left with just a 3. But I have to distribute, so the x remains to distribute minus x. So this is what they would give for the composite function. So really our kind of, for sure, final answer should be that and this. Okay. All right, last thing, and this won't take very long at all. This is, although it is the most important thing we do in this section. We're just going to go backwards. So we've been putting functions together as composites. We're going to now take a function that's a result of compositing 2 functions, split it back into its original parts, and we're going to just do this. It says express h of x as a composition of 2 functions. So we're saying h of x is equal to, like, let's just call the outside one f and the inside one g. So f of g of x. What's inside, what's outside? This is all about parentheses. If you can spot your parentheses, it's super, super simple. G of x is the function that is trapped inside a set of parentheses. Do you see any parentheses here? None written. So we have to think about where are the implied parentheses. Where are the parentheses that we don't write, but we know that are kind of there? Look for grouping mechanisms like fraction bars and root symbols. If you're typing this in your calculator, where would the parentheses be? Yeah, right there. That root, right? That root is grouped. And anytime we have a grouping mechanism like that, that's just a set of parentheses. Whatever's inside those parentheses, that's your inside function. So we're going to call that g of x. And then my f of x, the outside function, is to think about, okay, kind of scrub all that out, cover it up, erase it. What's left behind? Cube root. And what do I use to hold the place of the stuff that I've covered up? Just an x, just an x. So that's all we're doing. Think about the parentheses, the inside, we're going to call g. And again, names are arbitrary. We could name that whatever we want. But if we use that, letting g be the inside and f be the outside, that's all we do. Okay, so I'm going to turn this off. Thanks for watching.